What we need to explore here next is a topic they call related rates, and you'll see maybe, hopefully, why that those are called that when we get going here. But I've got the handout for you there, and let's just go through a couple of things. First of all, reconsider again dy over dx. Okay, so that's the first derivative. But what else can it mean? Well, the first derivative is the slope of the tangent. But it's also, in terms of wording, remember we talked about rate of change? And for dy over dx, that is the rate of change of the y with respect to x. Does that sound familiar? Dy over dx. Yeah, so the first derivative is also can be considered the rate of change of something. And in this case, it's the rate of change of the y, and then the dx, that's the with respect to part of that. Now, why did I mention that? Well, so the next thing, a there, if t is the time, then dy over dt represents the rate of change of y, but not with respect to x, with respect to t, with respect to time. The rate of change of y with respect to t, time. Okay? Now, I mention that because that's what we're going to kind of change gears here on with, is instead of doing derivative with respect to x, we're going to do the derivative with respect to t, time t, usually time t. Okay? So that's a little bit of a change. Now, what that also means is, so my second question there, what about blank? What about dx over dt? Yeah, so that's also going to be kind of a switch here, in that not only are we going to be doing the derivative of y with respect to t, but we're also going to be doing the derivative of x's with respect to t. And so that's sort of a change. It's not really a change, but something else we'll be considering. So that'll be the derivative of x with respect to t. So that's the rate of change of x with respect to t. Okay, so that's going to be something. All right, now, what does this mean as far as what we do, what the derivatives will be doing? Well, like I said, instead of doing ddx's, we're going to be doing ddt's. ddt's of expressions. So here's, for example, 1 in b, what I've picked out for an example here. So if I'm doing the derivative of that with respect to t, okay, well, 8y squared, no problem, that's just power rule, it'd be 16y, the first, right? Subtract 1 power, break down the powers, make the new power 1 less. But I'm doing the derivative with respect to t of a y. So there's another piece to this, and that's what we were talking about in our previous discussion. If I'm doing the derivative of something that has a y in it, and it's a variable other than y that I'm doing derivative with respect to, I need that dy over d whatever. In this case, since I'm doing the derivative with respect to t, I need dy over dt. And so that's kind of the switch here we're making. Instead of doing the derivative with respect to x, we're doing it with respect to t. And so instead of dy over dx, it'd be dy over dt. But it's the same idea. Okay? With me there? Now, on the second part of b there, what about the ddt of 7x cubed? Because previously, when we did the derivative and it had an x, we didn't need that dy stuff. But since I'm doing the derivative with respect to t now, here's what. This will be 21x squared, the derivative. But since I'm doing the derivative with respect to t of an x, I am going to need dx over dt that expression, that notation, expression, whatever. Is that okay? All right. So if you understand that, then let's jump here to C. So if we got y equals 2x to the fifth minus 3, let's find dy over dt. So dy over dt equals what? If you got x equals 2 and dx over dt is 4. All right? So we're looking for dy over dt. And we've got x is 2 and dx over dt is 4. Well, since this is what I'm looking for, that's telling me here, and this is the equation I start with, I'm looking for the derivative of y with respect to t. This is telling me I need to take my equation and do the derivative with respect to t of both sides. So I'm going to take the derivative with respect to t of both sides. So essentially what I'm doing is that implicit differentiation stuff we were mentioning in our previous discussion here. Taking the derivative with respect to t of both sides, because that's how I'm going to get this expression involved in this equation. All right, so the derivative with respect to t of that would be 1 as far as the power rule goes, but it is a derivative with respect to t of y, so I need the dy over dt with that. What about then this side? So I got to take the derivative with respect to t of this side. Well, power rule tells me that's 10x to the fourth, but I'm doing the derivative with respect to t of an x, and so I need the dx over dt also there. With me? All right, so now then it just becomes a substitution problem, because I'm trying to find dy over dt. I've got the x value, I've got the dx over dt value, so I'm just going to plug those in. X is 2, dx over dt is 4, and so dy over dt is 10 times 16 times 4. Is that 640? Check on that. Does that sound right? 10 times 16, that's 160 times 4, 640. Is that right? Okay. Tell me if I mess those up. I believe that's right. Is that okay? Yeah. All right. So D on this first handout anyway is y squared then minus 5x squared equals 16. So again, same deal. dy over dt is what if x is 2 and dx over dt is 10. Sort of a similar problem. I need to find dy over dt, and I've got those other two. So, same deal. ddt both sides. The left side would be, derivative would be 2y dy over dt minus 10x dx over dt. Yeah, again, need those dy over dt and dx over dt because we're doing the derivative with respect to t, and the variables are something other than t. So far, good? Equals 0. Because the right hand side is the constant. So the derivative is 0. Now, here's the reason I bring this one up is it's a little different than C because of this. I've got the x, I've got the dx over dt. I'm looking for the value of dy over dt, but what else do I need to know to solve that for dy over dt? I need the y value, don't I? This other one, when I did the derivative, I didn't have the y value. So it wasn't necessary here. So it's not given. However, in a sense it is. Because here's why it is given, or why we can find it. Actually, there's more than one why that would work here. But since I've got x is 2, and I've got this equation, can I figure out what y is from that equation? Yeah. I've got the x value, and I've got an equation that relates x and y, so I can find the y value off of that. So to find the y, just solve the original equation with x equals 2. So it'd be y squared minus 5 times 2 squared equals 16. And then we'll be able to plug numbers in and finish this problem out. With me there, so it'd be y squared minus, that would be 4 times 5, so it'd be minus 20 equals 16. Yeah, that one works out nicely. Add the 20, so y squared equals 36. Yeah, and so that's what I was saying. There's more than one here because y would be plus or minus the square root of 36. So it's plus or minus 6. Yeah, I think we can go ahead and just do them both at once here. All right, so we now know the y is plus or minus 6. So we've got 2 times plus or minus 6. The dy over dt is what we're solving for. The x is 2. And then our dx over dt is 10. So this is plus or minus 12 times dy over dt minus 200 equals 0. Yeah, so that's not too hard to solve there. So add the 200 and divide by the plus or minus 12. Let's see, that doesn't go evenly. 53, I think, or some equivalency there, right? I believe so. So dy over dt could have a positive 50/3 or you could have a minus 50/3. Either one could be your dy over dt. Yes, question? I think I got one more on the back there of the handout, and that is E. Let's see what E kind of stuff we get into with E. All right, so E, I've got 3 variables. Z squared equals x cubed plus the square root of y. All right, so here's the change I make for you on E. Find the rate at which Z is changing. If, with respect to t, when x is 2, y equals 9, dx over dt equals 5, dy over dt is 3. So I've started here a little bit, because where we're going with this is we are going to more of an application type problem, and so this is kind of our next step into that. What does this mean? Find the rate at which z is changing, and I left off with respect to t there. What is that? What is it we're looking for here? I'm not looking for a z value, am I? I'm looking for a rate at which z is changing. Well, that's our code words for what? The rate at which z is changing? That's dz over dt, isn't it? So if I'm looking for a rate of something at which something is changing, I'm looking for the derivative of it with respect to, in this case, t. So this is much like previous problems. I'm looking for a derivative, in this case dz over dt. Then I've got particular values to plug in to this. This is our equation. So yeah, if I'm trying to find dz over dt, I need to do the derivative with respect to t here on both sides to start this thing off. So I've got 2z be the derivative of that, but with respect to t, it's a z, so I need dz over dt. Same thing there, it's an x cubed, so that's 3x squared. But I'm doing the derivative with respect to t of an x, so I need dx over dt with that. Kind of a chain rule, remember where that comes from, kind of a chain rule thing. But and then square root of y, that's y to the 1/2, so the derivative would be 1/2 y to the minus a half, but it's a y with respect to t, so I need a dy over dt. Yep. So I'm pretty well set with that, because I've got x, I've got y, I've got dx dt, I've got dy over dt. However, and dz over dt is what I'm looking for, however, again, I need z, don't I? And so that's where, like on d there, I go with the x is 2 and y is 9, plug those into the original equation, we can find z off of that. So z squared equals, the x is 2, so that'd be 2 cubed, plus the square root of y, which is 9. So if I solve that, that'll give me my, my z values. Which again is going to be 2 here, it's 8 plus 3, so z is plus or minus the square root of 11. Okay? So let's plug those in here. Plug in the x is 2. Dx over dt is 5. 1/2 times y is 9, so we have 9 to the negative 1/2, times dy over dt, that's 3. So just plug in the values. If we don't round, that's just plus or minus 2 square root of 11, dz over dt. This would be 3 times 4 times 5, that's 60, plus, that's a half, that's 9 to the negative 1/2 is a third, because it's 1 over the square root of 9. So that's 1/3. Well, they're not going to cancel that, so this is just a half. 0.5. So let's say dz over dt equals 60.5, 60.5, divided by plus or minus 2 square root of 11. We could definitely write that in other forms, but when we get to these applications, we'd probably be rounding that off anyway, so some version of that. I'll put the final answer that I give in the back, but all right, something equivalent to that. All right.